Bismillahirrahmanirrahim. Students, today starting with a new topic that is one-to-one functions. We are going through three different types of functions, that is one-to-one, on-to, and inverse function. Now another name for one-to-one function, that is they are also known as injective functions. Now starting with the definition of one-to-one function, let f be a function from a set x to the set y. F is 1 to 1, or you may say injective function if and only if for all elements x1 and x2 in the set x, if f of x1, what is meant by f of x1? That is the value of the function at x1 is equals to f of x2, that is the value of the function at x2. If they are same, then this should imply that the values, the elements, that is x1 and x2, they were same. Or equivalently, you can say that if x1 and x2 are not same, then that is they are corresponding to two different values, then the values of the function at those points x1 and x2, they should also be not equal to each other, right? So this is the mathematical representation of the one-to-one function or an injective function, that is every element is basically going to have a distinct mapping in the arrow diagram of a function. Now let me explain the concept a bit in a detailed manner. The point here is that function may associate a different value of codomain to each element of the domain, right? Here the point is that once a function is one-to-one, then any two distinct elements of x are sent to two distinct elements of y, right? What is meant by this? For example, in case of the set x, let me say this is set x with say two values x1 and a second value that is x2, right? Now the set y having values say a and let me call it b. The point that any two distinct elements of x, यानी x के अंदर जो दो distinct elements हैं, दो different values हैं, they are sent to two distinct elements of y. That is, being a function, first point क्या है, first condition क्या है कि every element of x should be mapped to some element of y. ठीक है ना, वर्ड क्या यूज हुआ है, सम एलिमेंट ऑफ वाई, यानी जरूरी नहीं कि वो सारे एलिमेंट्स ऑफ वाई को कवर करेगा, लेकिन all the elements along the in the set x, they should be mapped to some value. There should not be a single element is in x that is not being mapped to a value in y. ठीक, और सेकंड कंडीशन क्या थी कि आपके कोई से दो वेरिएबल्स किसी एक वैल्यू ऑफ y को तो मैप हो सकते हैं, लेकिन एक सिंगल एलिमेंट ऑफ x cannot be mapped to two different values in the y. ठीक है, तो again according to the definition of a function, a strict condition is being applied over x. So a function that is called one-to-one or injective, the requirement is that x1 should be mapped to a distinct value of y, x2 should also be mapped to a distinct value of y. Then it will be called a one-to-one function. अगर ये दोनों x a को मैप हो जा सॉरी x1 is mapped to a, x2 is also mapped to a, it is a function. ये फंक्शन एग्जिस्ट करेगा, लेकिन उसको आप वन टू वन फंक्शन या इंजेक्टिव फंक्शन नहीं कह सकते, राइट. Let me show it with the help of a diagram. For example, taking the same example of set x with two elements x1 and x2 and another set y with two elements say a and b. If I may map the x to a and x2 is also mapped to a, then you can't say that it is not a function. It is definitely a function क्योंकि ये दोनों conditions, दोनों requirements यहाँ पे fulfill कर रहा है. x की सारी values मैप हुई हैं y पर और x की कोई ऐसी वैल्यू नहीं है जो y की एक से ज़्यादा वैल्यूज के ऊपर मैप हुई है. By definition, it is a function, but it is not an injective function. क्या मतलब है इंजेक्टिव का? यानी वन टू वन फंक्शन. It is a function, but you can't categorize it as a one-to-one function. Right? So this is the main concept that two distinct elements of x, if they are sent to the same element of y, जैसे x1 और x2 दोनों को हमने मैप किया a पे, then that function is not one-to-one function. Right? So let's do an example against it where we have to identify whether a given function is injective or not. For example, let me start with the first one. I have a set x with values a, b, c and d, right? Another set that is y with values say 1, 2, 3, 4 and 5, right? And let me represent it by a function g. The mapping criteria here is that a is mapped to 3, b is mapped to 1, c is also being mapped to 3 and d is being mapped to 5. Can you say that it is a function? Yes, definitely it is a function because it is following the basic definition of the function. The two properties, the two requirements are fulfilled here. But can you claim it as a injective or a one-to-one function? No, it is not. What makes it a non-injective function is that the value of a and b, यानी अगर मैं इसको मैथमेटिकली लिखूं तो g of a is equals to 3, g of b is also equals to 3. Sorry, g of c is also equals to, let me erase it, g of c is also equals to 3. But can you say that a and c are equal? No, they are not equal. They are two different values in the set x. So since two elements of x are mapped to a single element in y, that is both a and c are mapped to the value 3 in y, that is why it is not a one-to-one function. Right? Now let's do another question here. Say we have a set x having three elements 1, 2 and 3, and there is another set y having four values a, b, c, and d. And let me define a function h, which is from x to y, as follows. We are given with the mapping, that is h of 1 is equals to c, h of 2 is equals to a, and h of 3 is equals to d. Okay? So what we have to find is that either x h is a one-to-one function or not. We can do it with the help of the arrow diagram. Let's draw the arrow diagram here. Let me erase it. According to the given definition, the set X is going to have three members, that is 1, 2, 3, and the set Y is having four, which is A, B, C, and D. And according to the given mapping, h of 1 is equals to c, which implies that 1 is being mapped to c, 2 is mapped to a, and 3 is being mapped to d. Right? So can we say that it is a one-to-one function? Yes, we can. How? How the condition is being satisfied? If you say that observe that each and every element of x का हर element एक distinct value of y के साथ मैप हुआ है. कोई ऐसा element x का एक या दो ऐसे elements नहीं है जो किसी single value of y के साथ मैप हो गए. ठीक है? Every mapping is being distinct, so that is why h is an injective function, because every distinct element of let me write it here verbally, that is every distinct element of x is mapped to a distinct element of y, hence h is an injective function. Okay, let's move on and let's do another thing here, that is one to one functions on infinite set. इससे पहले जो भी हमने कवर किया है उसमें आपके पास फाइनाइट सेट्स थे, ठीक है, जिसने x के अंदर भी फाइनाइट वैल्यूज थी, y की भी फाइनाइट वैल्यूज थी, मैपिंग आपको गिवन थी, एंड जस्ट विद द हेल्प ऑफ एरो डायग्राम we can and determining whether the required condition of one-to-one function is met or not, inferred that whether a function is one-to-one or not. Right? Now we are going to a second scenario here where we are dealing with infinite sets. ठीक है, यानी infinite sets का मतलब क्या है कि हमें कोई भी function h given है that is having a mapping from x to y, then both these x and y they are infinite sets having a infinite domain and infinite codomain, right? So having a infinite domain or codomain, that is the set x and the y, there is a different perspective or a different method to judge whether a function is one-to-one or not. Right? So in what procedure that we are going to follow? Again, we are going to start with the basic definition of an injective function. और वो definition क्या थी कि for all x1 and x2 that belong to the set x, if f of x1 is equals to f of x2, then x1 should be equals to x2 यानी वो distinction ही की definition. So to prove that f is one-to-one function, one-to-one function, we are going to start with the supposition. First step में we are going to suppose or assume that x1 and x2 are elements of x such that f of x1 is equals to f of x2. ठीक है, हमने फर्स्ट स्टेप पे ये सपोज करना है कि x1 x2 दो एलिमेंट्स हैं जो कि सेट x को बिलोंग करें एंड फॉर दोज एलिमेंट्स functions f1 and f2 f of x1 and f of x2 they are same, they are having the same value. And from this supposition or this axiom we have to show that, taking this supposition at hand, we have to show that x1 is equals to x2, right? We are going to do it another way around, यानी इस चीज को हम suppose कर रहे हैं and the check is here that whether this holds or not. So if this condition holds or we are able to show that x1 and x2 are same, then our answer will be that the function is one-to-one, and if not, then it implies that it is not a one-to-one function. Again, this procedure in order to prove a function is applied only for infinite sets, right? Now let's start with a question against it. Let me define a function that is f having a mapping of a real number to a real number, यानी जो हमारा set x है that is a set of real number, or set y that is also a set of real numbers, and you can very well see here that it is basically an infinite set. Okay, set of all real numbers is may include 4n. And another function that is g, which is a mapping of integer set of integers to the set of integers, that is the set x belongs to a set of integers, set uh, y also belongs to the set of integers, and they are having a mapping. Okay? And by definition the function f of x is equals to 4x minus 1 for all x belonging to the set of real numbers, जो हमारी domain थी. And by definition the function जिसको हम say of n कह देते हैं, या बेशक इसको g of x भी लिख दे तो कोई फर्क नहीं पड़ेगा. चलिए मैं इसको चेंज कर देती हूँ यहाँ पे, that is g of n is equals to n square for all n belonging to set of integers. फर्क सिर्फ क्या है, let me write it here. The only difference here is that कि ये आपका x की जगह कैपिटल हो गया, ठीक है, जिसका एक मेंबर स्मॉल n है, उसको मैं m कह देती हूँ, या कोई भी वेरिएबल आप यहाँ पे ले सकते हैं. So the question at hand is that is f of n one-to-one function or is g one-to-one function or not. ठीक, we have to give a proof of it. Okay, let's start with the first one, that is a function f. Function f is having a mapping from set of real numbers to another set of real numbers, right? And by definition this is f of x, that is 4x minus 1 for all real numbers. So what was the procedure at hand? That is, we have to start with supposition for x1 and x2 are any real numbers, and we are going to take the assumption that f of x1 is equals to f of x2. So let me first write f of x1. क्या होगा f of x1? 4x1 minus 1. What is f of x2? This is going to be 4x2 minus 1. And with the assumption that f of x1 is equals to f of x2, 4x1 minus 1 is equals to 4x2 minus 1. यही होगा, मैंने दोनों को इक्वेट कर दिया. Now this plus 1 and minus 1 and minus 1, they are going to nullify each other. What we are left with is 4x1 is equals to 4x2, right? Let me continue it here. Sorry. Now 4x1 being equals to 4x2, you can very well say that x1 is equals to x2, both being the members of a set of real numbers. So the point here is that function f is an injective function, because we have come up with the proof that x1 is equals to x2, right? Let's move on to the second part, that is for the function g. Let me write it here. The function g was defined as a mapping of set integers to the set of integers, and by definition g of n is n square. Okay? Now and let me write it here. For all integers, n. Okay? Now starting with the same session, we are going to assume that g of n1 is equals to g of n2. What we have to show that by this supposition, finally n1 is equals to n2. So g of n1 is going to be what? n1 square. Similarly, g of n2, this is going to be n2 square. And if I may equate them, that is n1 square is equals to n2 square, and upon taking under root on both sides, I'm to have plus minus n1 here, plus minus n2 here. Can you infer here that they both are equal or not? No, there is a bit confusion here or an ambiguity here. In order to justify that the given statement is not correct, let me give you a counter example here. The counter example here is that let n1 is equals to 2, n2 is equals to minus 2. Both n1 and n2, they belong to the set of integers. And it is not mentioned that whether it is a set of positive integers or negative integers. Simply set of integers, जिसमें negative positive दोनों values are. So मैंने n1 n2 के against दो different values ली हैं. That is one is positive, second one is negative. That is 2 and minus 2. With the claim that g of n1 is equals to n and g of it is equals to g of n2, that is going to hold only under the condition that n1 is equals to n2. Let's see whether this is equal or not. G of n1 is equals to g of n2. n1 being equals to 2 square, and n2 being equal to minus 2. Taking the square of it. This is going to be 4 और -2 का square भी क्या होगा 4, right? And definitely both are same, यानी g of n1 की value equal है किसके g of n2 के. Both are having the same value, but are we having the same values for n1 and n2? No, not at all. They are different. One is positive, the second one is negative. That is why we can't claim that g is an injective function. Mathematically, what is the reason behind that? The reason here is that g of n1 is equals to g of n2, but n1 is not equals to n2. They are having the same, different values, but the function is evaluating the same value. So this is a procedure that you have to follow while making use of, in fact, how to prove that a given function is injective or not, especially for the case when we have infinite sets. Okay, let's do one last question here. A set X with 4 values and another set Y with 3 values, and the given mapping is function is G, that is having a mapping from X to Y. From the given arrow diagram, we can claim that G is a function because it is fulfilling the properties of the function. But here you can see that G of A is equals to G of B is equals to G of D, all being mapped to F, right? But A is not equals to B is not equals to D. All these three are distinct values. Similarly, G of C is being mapped to E, but since these three are not mapped to three distinct values, G is not an injective function. Now, one very important question here. With this given, uh, in fact, with these given sets X and Y, can there be any possibility in order to make sure that G is a one-to-one function? Can we make such an arrow diagram that every distinct element of X is being mapped to a distinct element of Y? No, it is not possible. Why is that so? Number of elements in set X वो क्या है 4, number of elements in the set Y, they are 3 in number, right? In order to ensure the distinct mapping, यानी हर एक separate element x का एक different value of y के साथ मैप हो, the codomain should also contain 4 values. ऐसा ही है ना? लेकिन 4 different values हुई मैपिंग के लिए सेट y के पास भी 4 different values होनी चाहिए. It is not possible कि वो 4 values को 3 values के ऊपर अगर मैप करेगा तो definitely at least one of the members of x is mapped to the same element in y. ठीक है, कोई ना कोई एटलीस्ट 2 एलिमेंट्स ऐसे ज़रूर होंगे जो सिंगल एलिमेंट ऑफ y को मैप हो रहे होंगे. So with this size of the set, that is the codomain is having a value or size which is less than the domain, there is no possibility to have a one-to-one function. So, can we have a threshold or a boundary on the size of the set that the codomain of x, the domain of the function and the codomain of the function, that is y, they should be at least same. वो दोनों का size क्या होना चाहिए? Equal होना चाहिए. In order to ensure that you can have a possibility to have a one-to-one function. और एक बेटर कंडीशन क्या हो सकती है कि आपकी जो कोडोमेन है दैट इज हैविंग अ साइज व्हिच इज ग्रेटर देन द साइज ऑफ डोमेन, यानी में उसके अंदर आपके पास जो नंबर ऑफ एलिमेंट्स हैं वो अगर ज़्यादा हैं देन easily this is for sure that you can map each and every element of x to a distinct element of y because you are given with a wider space. आपके पास अपॉर्चुनिटीज चॉइसेस ज़्यादा हैं. अगर इक्वल हैं तो भी आप इजीली डिस्टिंक्ट मैपिंग कैरी आउट कर सकते हैं. बट द मोमेंट आपकी नंबर ऑफ एलिमेंट्स को डोमेन में कम हो जाती हैं देन देर इज नो चांस टू हैव एन इंजेक्टिव फंक्शन, राइट? So this brings me to the end of the lecture. Do thoroughly go through it, and if you people have any queries, any questions, we are going to discuss it in the interactive session. Thank you.